Alright, this is the second video in the series. So if you haven't watched the previous video, you should watch that first. We've already done problems 1 and 2, but the directions are that we are given one trig value and the quadrant, and we're being asked to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So that's what we're going to do now for problem number 3. First of all, what quadrant are we in? Let's see. So the angle is between 90 and 180. So that puts us in the second quadrant. So let's go ahead and draw our diagram into the second quadrant. Alright, so we're talking about an angle whose terminal side is in the second quadrant. So I'm going to go ahead and draw the reference angle, making a triangle out of it. Okay, secant is the reciprocal of the cosine function. So whereas cosine is the x value over the radius, the secant is going to be the radius over the x value. Now the radius is always positive. So this 4 must be the radius. Now the x value can be negative. So I'm going to take this negative sign and stick it on the 3 because that must be my x value. So in terms of this diagram, I know that the radius is 4. My x value is -3, which would go here, which makes sense because it's to the left. Now what I need to find is my y value, and can we agree now that this y value is going to be positive because it is up? So when I take the square root and I find myself saying plus or minus, like is it going to be plus or minus something, I'm going to choose plus because y value in this quadrant is positive. So Pythagorean Theorem is what we're going to have to do to find this y value. So let's see, I've got x squared plus y squared is equal to the radius squared. So that's going to be 9 plus y squared is equal to 16. Subtracting 9 from both sides, I've got y squared is equal to 7. So that means that y is equal to, now normally I would say plus or minus the square root of 7. But as we discussed, it has to be positive. So I'm just going to say y is equal to the square root of 7. Okay, so that is the information that we're going to need to do the problem. Alright, let me just erase this for a moment. Okay, so we are supposed to find sine of 2 theta. So let's find that first. According to the formula, sine of 2 theta is 2 sine cosine. So I'm going to do 2 sine theta cosine theta. Alright, so that is going to be 2. Sine is y over r, so that's going to be radical 7 over 4. Cosine is x over r, so that's going to be -3 over 4. So there's 2 sine cosine. So what am I going to do? So this will be, looking at this like it's 2 over 1, I'm going to have -6 radical 7 over 16. Alright, and I think we're at the end, so I'm going to go ahead and say sine 2 theta will equal -3 radical 7 over 8. Alright, I just reduced 6 over 16. Alright, so that is the first thing that we were supposed to find. Now let's go back and find cosine 2 theta. Alright, according to the formula, cosine 2 theta is cosine squared minus sine squared. Okay, so it's going to be cosine squared theta minus sine squared theta. Alrighty then, cosine is x over r. So that's going to be negative 3 over 4 squared. Sine is y over r. So that's radical 7 over 4 squared. So that's going to be 9/16. Alright, I'm squaring this. Minus 7/16. Alright, radical 7 squared is just 7. And so I think we're coming up on the final answer. So I'm going to go ahead and say cosine 2 theta equals you know what, I guess this will reduce a little bit. So this is going to be 2 over 16, which reduces down to 1/8. Alright, so cosine 2 theta is going to equal 1 over 8. Now it is time for tangent, which is always sort of the trickiest one. Alright, it's the most complex formula, so here we go. Tangent of 2 theta. Now according to the formula, that's going to be 2 tangent over 1 minus tangent squared. So I'm going to have 2 tangent over 1 minus tangent squared. Alright, here we go. So I'm going to have 2 times tangent, and tangent is y over x. So this is going to be radical 7 over negative 3. And then I have 1 minus tangent squared. So that's 1 minus, and again I have this radical 7 over negative 3 squared. Okay, so looking at this like it's 2 over 1, I'm going to have 2 radical 7 over negative 3 in the numerator. When I square this, I'm going to get 7 over 9. Radical 7 squared is just 7. Negative 3 squared is positive 9. And now the 1. I need like denominators, so I'm going to write the 1 as 9 over 9 so that I have like denominators. Okay, so in the numerator, I still have 2 radical 7 over negative 3. And this will be 2 over 9. Okay, when you divide fractions, you multiply by the reciprocal. So this will be 2 radical 7 over negative 3 times 9 over 2, multiplying by the reciprocal. Now I'm noticing that these 2's will cancel each other out, so they're gone. And also 3 goes into itself once, 3 goes into 9 3 times. Alright, notice that the negative is not going away. So I think it's time to write the answer. So I'm going to go ahead and say tangent 2 theta equals. So it'll be negative because the negative is still there. So I'm going to have negative 3 radical 7. You know what? I guess there is no denominator. So it'll just be negative 3 radical 7. Let me just rewrite that. Okay, that wasn't so bad. Alright, take a look at number 4. This angle is between 0 and pi over 2. So that's going to be good old first quadrant. So let's draw our angle into the first quadrant. And let's go ahead and make a triangle out of it. Okay, of course, sine is y over r. So that tells me that the 4 is going to be the radius, and this y value here is 1. And what I need to find is the x value. And this is definitely going to be positive because it is going to the right. So just keep that in the back of your mind as we do the Pythagorean theorem. So x squared plus y squared is equal to the radius squared. So x squared plus 1 is equal to 16. So x squared is equal to 15. So x is equal to plus or minus the square root of 15. But as we discussed, it has to be positive, so I'm just going to say the square root of 15. Alright, that is the information that we need in order to keep going with the problem. So let's go ahead and find the sine of 2 theta. Alright, according to the formula, sine of 2 theta will equal 2 sine cosine. So this should equal 2 sine cosine. So that's going to be 2. Sine is 1/4. That was given to us in the first place. Cosine is x over r, so that'll be radical 15 over 4. Okay, so that is going to be 2 radical 15 over 16, right? And so that means it's time for the answer. So sine of 2 theta is equal to radical 15 over 8. Alright, just reducing this down. So that is the first part that we were supposed to find. So now let's go back and find cosine 2 theta. Alright, according to the formula, cosine 2 theta is cosine squared minus sine squared. Alright, so we're going to do cosine squared minus sine squared. Fine. Cosine is x over r, so that's going to be radical 15 over 4 squared. Sine was given to us in the first place, so that's 1/4 squared. So that is going to be 15 over 16. Radical 15 squared is just 15. Minus, and this is going to be 1 over 16. All right, and that's going to equal 14 over 16. So time for the answer, cosine of 2 theta is equal to 7 over 8. Okay, that leaves one more thing to find, and it is always the most cumbersome, the tangent of 2 theta. All right, so here we go. According to the formula, tangent of 2 theta will equal 2 tangent over 1 minus tangent squared. So we're going to do 2 tangent over 1 minus tangent squared. All right, that is what is about to happen. All right, so I'm going to have 2 times tangent. Now tangent is y over x. So tangent is going to be 1 over radical 15. So that's 2 tangent. And then I'm going to have 1 minus tangent squared. So that's 1 over radical 15 squared. Okay, so it's just a matter of simplifying this down. Looking at this as 2 over 1, I'm going to have 2 over radical 15. And let's see, if I square this, I'm going to have 1 over 15. All right, and then I'm going to write 1 as 15 over 15, so I have like denominators. So this is going to give me 2 over radical 15 over 14 fifteenths. Okay, interesting. So it is time to multiply by the reciprocal in order to make this happen. But I can tell already that the numbers will work out better if I rationalize the denominator. So I'm going to rationalize the denominator right now by multiplying the numerator and denominator by radical 15. Okay, so that is going to give me, and I have space, so I'm going to do it down here. So that's going to give me 2 radical 15 over 15. Okay, and that is over 14 fifteenths. Alright, so I just rationalized the denominator in the top part. Okay, now I'm going to go ahead and multiply by the reciprocal. So this is going to give me 2 radical 15 over 15 times, and now I'm going to do the reciprocal of this. So that's going to be 15 over 14. Do you see why I rationalized the denominator ahead of time? So now I can easily see that these 15s are going to cancel each other out. That is why I did that, so it would work out very nicely. So that is going to give me, so now I have 2 radical 15 over 14. Okay, so I'm just going to put the answer sort of up here where it goes. Alright, so tangent of 2 theta equals, and just reducing this, it will be radical 15 over 7, because 2 goes into 14 7 times. Alright, and that is it. And I'm going to go ahead and stop the video here. Alright, this video is long enough, and I think we're switching gears a little bit on the next problem anyway. So if you're interested in what's coming on problem number 5, I will see you on the next video.